I'd like to introduce John Bertram, and he's going to talk to us about what is fabric content, what is it, and why should we care? Those are awesome questions, John. Take it away.
Okay, thank you. So good morning, folks. Obviously, we're interactive. You can ask questions. What I wanted to talk about this morning is a new technology that's emerging out into the marketplace right now that will fundamentally change how we design and implement Ethernet-based networks. And this is, I've been in the industry, well, probably, as you can tell from my hairline, well over 25 years, almost 30 years. And this is one of the few times that I've seen a technology that could dramatically change how we do things. If we think about the past 15 or 20 years with Ethernet, what have we done? We've gone faster. Essentially, that's it. There's been lots of protocols added. There's been a lot of things done from a multicast and from a routing point of view, and there's certainly been a lot of complexity added to the networks over the years. But essentially, we're running faster. We've gone from 10 to 100 to gig to 10,000. So I want to talk about this new technology, and we talk about our Fabric Connect, but really what we're talking about is something called shortest path bridging. And shortest path bridging is a technology that came to us from the carrier Ethernet world and the optical world. And it's something we've developed in the enterprise space. And the first applications they looked at was from a data center point of view. And it has some great applications there. But what we're most interested in is what are the applications across the entire enterprise, not just the data center, and how can it simplify? And that's what I want to spend the next half hour or so talking about. So here's what I want to talk about. I want to talk a little bit about our innovation and our leadership in this space, what we've been doing. We've been in this business for quite some time. For those of you that don't know the history of Avaya from a networking point of view, it goes back to the Synoptics, Bay Networks, Nortel, and then Avaya. And a lot of the products that are out in the universities go back into those heritage days, back into the 1990s and so on. I'm going to talk about some of the drivers for fabric technology, what's causing the industry to change. I'm going to talk about what it means from an open standards point of view and what we're doing there. And I'm going to talk about a couple of solutions so you can sort of see and frame how does this work and why you would want to look at this. So let me kind of start off with a little bit of history. In 2010, some folks may remember the Vancouver Olympics. This network was built solely on a Avaya solution at the time. We partners with Bell Canada to deliver the first all-digital games in 2010. In this environment here, we delivered a huge network consisting of our a full line of Ethernet switches using our multi-link trunking technology. This is a technology where we remove spanning tree from the network. And we've done this for probably 12 or 13 years. Something we're now starting to see a lot of the other vendors pick up on in the last few years. And this delivered a pretty phenomenal network. When you think about it, let me kind of give you some statistics to think about. So the things that I like to think about here is, we did almost 5 billion bytes of data delivered over the course of the games. It was 17 days in terms of how it ran. And if you think about it in terms of the complexity, the logistics, the information has to move, this is like doing, 3 Super Bowls every day for 2 weeks plus in terms of the network. And the network ran absolutely flawlessly with no downtime. And this was a major milestone in terms of this, the first time they'd ever done it from a digital point of view, all digital. And the same thing from a voice point of view, it was all digital. From a voice point of view, we did 750,000 calls in that time frame, in the 2-week time frame. So definitely, was a blueprint to how we kind of get started in this. What's interesting now is Now that we're at the 2014 Winter Olympics, we've also been chosen as the vendor of record here. In this environment, we're moving to this new network technology called SPB. And in this environment, if you look at it, what we're able to do here is we're able to build virtual service networks across a common architecture very quickly and very easily. And that's what I'm going to talk about, ease and simplicity. So basically what we've done is we've built large networks to service the games, to service their internet, to service their telephony, to service their admins. We could also layer out one for the press. We could layer one out for different things as we need those networks and turn up those network services very, very quickly. So I'm going to talk a little bit about that. The complexity around Sochi is kind of interesting because if you think about it, you know, there's two cities that are 50 kilometers apart in terms of logistics. So lots of fiber, lots of connectivity issues around getting the stuff between the two locations and making sure that everything works flawlessly. So, you know, it's extending the network across the space that we have and making sure that everyone has connectivity because, you know, for sure there'll be someone that wants connectivity from that's in one site and then another venue. And we have to make those services available very quick and very fast. This network's been up and running now for about a year in preparation for next year. We're just in the final stages now for turning it all up. So, you know, we're expecting it to be a revolutionary. And this will be not the first large SPB deployment. I'm going to talk about another one in a second, but probably the largest and most complex in its nature. And this network, the full network is running SPB or Fabric Connect. One of the ones that's more recent that you may have heard about is Interop. So Interop this past May, the backbone network was fully run on an SPB core. And in this SPB core, we were able to deploy services very, very quickly to users. So let me kind of just give you a little bit of a highlight around why is it so important to look at this? Well, what happens in an SPB network is you define your core network one time, configure it one time. Very simply, you run a protocol called ISIS in the core, and then you only provision services at the edge of the network. So if I needed a layer 2 VLAN extension from this building to this building, I would provision it at the edge of the network and not in the core. So regardless of how many devices I have in the core of the network, I would never have to touch them. So think about it from a simplicity point of view. All I have to do is say, I want VLAN, I want a VLAN for telephony from here to here, and it would show up in those buildings. That's the simplicity. For environments like this, where it's a trade show, where things are very fluid, people want connections quickly and they move around a lot, the time to deploy was significantly less. We deployed this, I think, with 6 engineers in 3 days, what normally takes them 2 weeks to deploy with a team of 20 odd people for the same thing. So why is that important when you think about it in an education environment? Resources are always tough to find. You know, projects are always hard from a prioritization point of view and getting the right resources. So here is a way to manage and work the network in a much more simpler way. So I'm going to talk a bit about some of these. There's kind of some interesting things here. I mean, there's lots of top 10 things from Gartner, but you know, one of the ones that I really think is complexity. You know, we have gotten very complex in how we design our networks. And some of it is just due to the fact that, you know, we've got product limitations and so on in the way that things are designed. And I think in some cases, that's not the right approach. And that's one of the reasons that we believe from a Fabric Connect point of view, simplifying the network architecture is a top priority because we don't have limited resources. We need to make things simpler. And when you think about it at the end of the day, simpler always translates into more reliability. If it's more complex, there's more places to go. And if I think about the example I talked about where I wanted to provision a virtual LAN or a VLAN between 2 buildings, in a core network of 10 nodes, okay, in a previous, an MPLS network, for example, I would have to touch every one of those core nodes to propagate the VLAN information across. In this SPB world, I don't do that. That information is never touching the core. So my simplicity is I just touch the edge. My impact is, if I make a mistake, is the edge. I don't impact the core. Significant difference. So if I think about it here, and this is kind of where it starts, if you look at it from a data center point of view, the requirements are really for redundancy between the servers, right? You want to have VM images and you want to have backup capabilities. You want to be able to have mobility from a VM point of view. So think about this. I now have the ability in an SPB cloud to have two data centers disparate across geographic boundaries, and I could do a VM move, a vMotion move from one data center to the other of a appliance instantaneously. And it would take seconds to do. Don't have to plan an outage. I don't have to plan a maintenance window. I just simply make the move. I don't have to reconfigure the core of my network to accommodate the move. That is significant from an architectural point of view over what we've done traditionally in the past. If you guys get a chance to come up to see the vendors exhibits, we have a demonstration up there where we're showing some of this stuff. We're running a small SPB core, and you can actually see the impact of making moves and changes. The other thing to think about is also east-west traffic is becoming more relevant in the data center. Not so much so, it used to be like 80-20, the traffic went north-south. Now it comes down and we're pulling data. So the ability to have high bandwidth between devices in the data center is extremely important. And again, this technology allows us to do that. We have the capability to stack our Fabric Connect boxes together with 120, 240, and 480 gig aggregation links. So if you think about this, when you're running 10 gig servers, having these high-speed aggregation links, extremely important. And as I mentioned earlier, the plug-and-play services point of view, extremely easy to do. I can simply make the move from one server to another instantaneously. If I think about virtualization, why would you do it? It's cost, right? Why did we start the whole virtualization? I want to maximize what I'm doing with one server across multiple applications. What SPB allows us to do is to do the same thing from a network point of view. So if you think about an Ethernet switch in its simplest terms, it's a 24-port switch. What I'm talking about with SPB is taking that 24-port switch and blowing it up, putting it everywhere in the network. A piece of it would live everywhere. So it's virtualizing as well our Ethernet switching capabilities. So I don't have to have a physical switch that has it. I could have it virtual across. It doesn't have to be in the same box. It could live in multiple places. And that's really kind of interesting. And also from, as I mentioned, from a provisioning point of view, the ability to do one-touch provisioning, as I want to drag this service from here to here. Really important. So the network virtualization is enabled through this technology called shortest path bridging. When we look at our implementation of Fabric Connect, it's based on shortest path bridging, which is an IEEE standard. It is a ISIS protocol at layer 2. And it's what we've done at Avaya is we've added extensions to the standard to support layer 3 and multicast. And you'll see the services that we support over and above where Fabric Connect started or where SPB started in the data center. What's really nice here is we believe it's a consistent architecture you can apply across the entire network. It's not just for the data center. So it can be used in the campus, it can be used in your closets, in your core, your distribution layer, whatever. We will support any topology. Ring, star, mesh, box, square, doesn't matter. No loops in the network. You cannot have a loop in spanning or in SPB. It does not exist. Not physically possible. Even though you have a physical loop, there will not be one existing from a network topology point of view. So As I mentioned, this is really a game-changing functionality in terms of how we design networks. So let's kind of look at this. If we think about it, we get efficiency in the fact that we now provision only at the edge of the network. It's one command. I mean, literally, VLAN ID, ISID, and that's it. And you're done. It's very fast from a convergence, a heal, and a move point of view. You can look at our demo upstairs. We're running a video stream across the network in a triangular network. So it's going down one path. If we pull the link, you may see some pixelation in the video. You likely won't even see a ping drop in it. And you can pull the links back and forth. So while if you look at some of the routed networks like OSPF, you can do that in OSPF. If you pull a link, it'll reconverge. It's very quick. Even with spanning tree, it's very quick. But try putting the other link out after that and then going back and forth. Doesn't quite respond the same way. This is all like a microsecond failover times. Very, very fast. Flexible. Extends the services seamlessly across the network. You can get layer 2, layer 3 multicast services, VRF instances, wherever you need them. So if you've got your big router here in the network, you can virtualize it and provide those services across the entire network. Secure. This has a significant difference, from the VLAN provisioning where you have the ability to jump VLANs. So you have some inherent challenges there. In this environment, not the case. SPB does MAC and MAX encapsulation. So we've already changed the way that the header looks and the way that the packets look. So much, much more difficult to do. If we think about it in terms of the services now, here's kind of where we started. We started with the layer 2 service, okay? Being able to provide a layer 2 virtual LAN seamlessly anywhere in the network. That's the standards-based approach. In addition to that, what we've done is the ability to do IP shortcuts. So if you want to just route .10 to .20, we can do that. You just configure it and you're done. No routers required, nothing else required. However, if you want to do a whole layer 3 virtual service, we can do that as well. So you could say, okay, this is a whole layer 3 virtual service that's going to be delivered. And then we can tie those layer 3s together using what's called an inter-VSN routing protocol. And again, you can virtualize your routing in this model. So it could be wherever you want. It could be in your data center or whatever. And the last one is multicast. And I'm going to spend a couple minutes later talking about this in a little more detail because I think the multicast one is one of the strongest things that this brings to the table. Our ability to map IP multipass groups into a virtual service group. So the ability here is that you no longer require PIM, you no longer require bootstrap router, rendezvous points, all of this sort of stuff. This is all done at layer 2, IGMP joins. It's totally simplistic and totally scalable. And I'll talk about an example in a minute on that. So when we think about it here, what we're able to do is we now have one fabric across the entire network that will support any service anywhere at any time. So it's very, very flexible in how it delivers it. We get granular separation between our layer 2 and layer 3 services, which is really nice. So if we think about it in environments where we need multi-tenanting, or even in a university environment where you've clearly got a delineation between your student population and your faculty population, great in terms of how it would segregate that. Tenants can be applications though, it could be services, whatever. And it can be deployed very quickly. So how does this, if I think about it in terms of the comparison to how we have traditionally built networks, we've traditionally built networks this way, vertically. Started with a base layer, we've added on a bunch of protocols and things that we've needed in order to get things done. And this has gotten very complex in terms of networks. If you look at the network admin side, having this skill set, it's not only time consuming, but it's costly. What we're doing in SPB environment is a horizontal that are independent. So you can deliver these services independent of each other. They're not reliant on anything else in a stack. So it's totally different in terms of how we deliver services. And I'll sort of show you that here in a second. So I mentioned this one earlier, but from a data center point of view, here's a good example. If I had, from a data center point of view, I wanted to create a layer 2 VSN, I could just simply provision at the edge a layer 2 VSN for all those servers. And all those servers would now live in that layer 2 domain. And that would give me the ability to drag and drop vMotion or whatever services I need across there. I could have multiples of those layer 2 domains. I could also have layer 3. Now, if I wanted to do that in a regular routed network, I would have to start to get, especially if there was, distance involved, have to start to talk about some type of MPLS or VPLS type service. This is not required here with this. I then have the ability to route between my layer 2 by using my layer 3 VSN service. So it's very simple. The edge devices only have to be touched. I don't have to touch any of the core devices, and very, very easy to deploy. So if I think about it here, and this is a data center example where we're using kind of top of rack scenario, you just have an amazing ability to scale the fabric. As I mentioned, we can connect these switches together with up to 480 gigabit links between switches. So if you're thinking about it in a data center type application, daisy chaining switch after switch to connect your and aggregate your servers, normally you'd have to do that with 10 gig links. So how much would 48 10 gig ports cost to go between two switches? About $1,000 a port. Our cable costs, I don't know, $1,000. So the ability to extend this fabric across a large data center is a huge play. Here's the one that I really like, and this has to do with multicast, and I'll take you kind of through this example. So if I've got a multicast sender and he would send out to these streams, let's assume that none of these exist right now. He's just set up. None of the multicast traffic would actually hit the network. So the core is intelligent enough to know that no one subscribed. So it does not propagate the multicast. But as soon as the first person sends an IGRP join here at the edge, what happens is the core sends a reverse truffle byte here, a management byte back to this guy that says, I have someone that wants to join. This edge node then converts it to a unicast and sends it to this node. Now this node has the stream that can be propagated out layer 2 to this guy. None of the other nodes have to see that or will see that traffic. If someone joins down here, then this node would be notified, would notify backwards that it wants to subscribe to the stream, would be converted to a unicast and sent to that stream. The interesting part here is that as you scale this out, the more people that join, the faster this actually starts to work because you already have the stream at the edge and it's easy to deploy. There's no need here to get into things like the complexity of PIM. This is also much easier to troubleshoot because your path for your traffic is always the same. It's always the shortest path. Unlike in PIM where you're going to a rendezvous or a bootstrap router, in one case, the traffic might flow one way and then it's converted and then it goes a different way. So can be somewhat complicated. The other side of it is, it really plays well into things like IPTV applications, if that's something you're looking at, or video surveillance. Being able to scale this into, thousands of devices is possible. And that's not something that's possible with routed networks today. You try to do, hundreds of endpoints from an IP multicast point of view, it just craters from a routing point of view. It's been extremely difficult. I mentioned simplicity earlier, and I put this slide in, not that it's real technical, but just to show the fact that if I wanted to create a layer 2 in SPB, I say config a VLAN 7 and I configure ISID 700 on the edge device, do that on this edge and on that edge, and I'm done. If I did the same thing in a VPLS, MPLS world, these are the commands that I would have to do, and I would have to touch every node or every router in the network that was in that path. So you tell me what's more simple, this 2 times, or this however many times you have routers in the network. Substantially different from a simplicity point of view. And that's one of the key things that we're driving in terms of change. Same thing from a configuration here. If I want to do layer 2, layer 3, if I want to do multicast, I want to turn multicast on, it's one command. One command in the core to turn multicast on. It's done. Nothing else. Incredibly simple. So I kind of look at it this way and say, you know, it's your choice. You know, do you want to kind of go this route or this route in terms of how you deliver services and how you turn things up? If you think about it, the time to deliver services in this environment is usually minutes, hours at worst. In this environment, it can be extremely long. If you asked in most networks today, I wanted to turn up a new service, you're probably talking an outage, you're probably talking, you know, a week, 2 weeks to get the change requirement in. We're talking about doing it instantaneously, doing it on the fly, and doing it with no impact on the network. And that's fundamentally different. And I think that's really one of the key things that drives a lot of the technology around SPB. So if I think about it here, in this environment could be, you know, an environment where we've got multiple locations. I could deliver multi-tenanting very quickly. I could create one virtual service group for secure zones. I could have my guests on a different secured zone, all on a common infrastructure. I could have my partners on a different zone, all configured by just configuring a network very, very quickly. And I could have layer 2 and layer 3 in this network. I could provide them a UC environment very quickly, deployed. If I think about this, you know, where we talk about, you know, PCI compliance and so on, it becomes extremely important. Being able to create totally synced networks, being able to have total separation between each of these networks. So I could have a secure zone and it goes out to these locations. I could then say, I want my UC though to go to other locations and it would only go to those locations. I could have guest zones only are in this part of the network. And again, these are easily deployable by touching and impacting only the edges that they touch. So in this example here, if I was deploying a guest network in my complex network and it touches 4 buildings, I would only have to touch 1, 2, 3, 4 boxes to configure that service. Dramatically different than what most networks are today, where, you know, if you think about BYOD, for example, most organizations are reluctant to do it because of the impact that it has and the changes that they have to make across the entire network. This could make it very simple, very straightforward. You could also create zones for contractors or guest employees that are coming in. So something to think about in terms of traffic separation. If you look at it, you know, before we were doing SPB, this is what we had to deal with. Complexity. We had to deal with slow recovery. We think about OSPF and these sort of things. Extremely, you know, vulnerable to security breaches. In an SPB environment, it's a single protocol we run in the core. It's called ISIS. It's easy, very, very easy to configure. The fast recovery is sub-second. Like I say, if you get a chance to go upstairs and see it in the booth, it's absolutely astounding how quick the network will recover from a link failure or multiple link failures. Not something you would see in a traditional routed network. Also, just from a traffic isolation point of view, it meets all the regulatory requirements. You know, it's secure. You don't have the ability to jump VLANs and so on. So if we think about it, you know, we keep a L3 network over the fabric in that environment. It's really kind of cool in terms of how you do it. And if you think about it, it's like I've got this core network that's running ISIS, but I now have my routing, my virtual services running over top of the network. So it's kind of like almost like you've got a plane flying from here to Vancouver. While it goes across the country, it doesn't touch all of the cities, but it's handed off between all of those cities. But it doesn't have to know about all of those cities. The other thing to think about is just from an encapsulation and an edge point of view, because the core network is only running a layer 2 ISIS, it doesn't have to know about any of the edge devices. So the edge devices or the MAC information has only local significance. So you can build some pretty large flat networks now, which ideally is what we wanted to do in the beginning, but ran into all kinds of issues around it. So it's an interesting approach when you think about it. So if I have 2 virtual LANs, and if I were to look at the edge switches, this edge switch down here would only have the MAC addresses of this domain, this L2 domain. The other edge switch would only have its L2 domain. They wouldn't have each other's. But it would know if it needed to go there, how to get there through the fabric. But it doesn't have to have the table propagated. So when you think about the core, this is one where you talk about multi-tenancy and compliancy point of view. The core of the network never sees any of the MAC addresses from the edge. Doesn't exist. There's no MAC forwarding table in the edge. So it's kind of interesting. If we think about it here, this is kind of from a video surveillance point of view. I don't know if you've heard of a company called Pelco. They're probably one of the world leaders in terms of IP video surveillance cameras. Pelco approached us on this technology a little while ago because they ran into the problems when they tried to scale this into the hundreds of cameras in a routed network. The CPU utilization on the router is just crater. And it doesn't matter whose router you use, it's the same problem. Even if you're using our routers in a traditional network running PIM or whatever. Typically what they would find is they could run about 450 routers, or sorry, 450 end stations before the network would start to kind of have issues. So they came to us, we started talking about deploying this on a SPB network using the Multicast feature. What we found here was they were able to deploy 750 end stations. They ran out of end stations, and it ran flawlessly. And when they looked at the core, which it's not involved in the IP multicast, they saw the CPUs sitting at 6%. So there was no impact in the core of them running a significant, 750 IP streams of multicast. So it was huge. And it's something that, they were able to do, very, very easily and very interesting. So going forward or back? Here we go. I just went backwards there. I had that same slide. So, again, what we believe is from a benefits point of view, we think that, you can quickly deploy networks. You can quickly deploy layer 2, layer 3 networks, multicast networks. In this environment here, it's regardless of the topology in the core. So in this environment here, this is the only device and this device that would know about the information, VLAN information or MAC information. None of these other devices would know or care. So, and then when data comes in here, it would always forward it on the shortest path to that other side. That's how it works. It's simple, straightforward, easy to use. Uses, as I mentioned, the standards. It's built on Ethernet standards today, AQAH and AG. It's totally flexible in terms of the technology for layer 2 and layer 3 virtualization. It's very efficient. It uses all the paths in the network. There's no loops in the network, even though there's a full mesh topology. The time to converge is extremely fast. It's PCI compliant. If I think about it here in an education environment, it's true network separation, multi-tenanting, and scalable multicasts. Those are all key advantages when you think about how do we deploy networks. So my last slide here, I'll leave with a sort of product pitch is, across our product line, all of the products that we're deploying right now in the network, this is where we're going. All of these either have or will have our Fabric Connect technology in them by the end of this year. And it's an exciting new time for us in terms of how we can design networks. People just don't believe how simple it is to do. They can't quite understand that it can be this simple until they've seen it. And we've had probably about 15 or 20 customers come up here to Ottawa. We run a 2-day workshop for them and say, this is how you do it. And they walk away and go, I can't believe it was that simple. And they've went and deployed it. And it is absolutely that simple. So I appreciate your time today. And if there's any questions locally here in the room that you might have, I'm around for some questions, or if there's anything virtual.
Nothing virtual yet.
Okay.
I just ask that you repeat the question for the.
Okay, if there's anything that they have from a question point of view, please put it on the on your window, and
we'll do. And if you get any questions in the.
Go ahead, Peter.
So, question. I see it's coming for the ERS 4800 series.
Yes.
I don't see any 5000 series out there. So, is it required in the edge, or like can you deploy this in a network?
It's an excellent question. So so the question was, is it required in the edge device, and is it required in all the products? So no, it's not. The further you can push out SPB, the simpler your administration deployment becomes, because that's where you're touching your devices. Doesn't mean that it has to be. You can just think about this. If you have 15 devices in your core of your network and you run SPB in the core, you now no longer have to touch any of those devices when you do a change on your edge devices. So that's a significant savings just on its own. So we have a lot of customers who are just doing the core. And then we have customers that are doing the full edge. The 4800s that are out there in the field today, most of those are upgradable to the VSP 4000, so VSP 4000 code, so you can get them. The 5000s not, because the hardware doesn't support it. There is a new version of 5000 coming into next year that will support it from an edge point of view as well. So,
how well do you play in either a mixed environment
Sure.
in the long term or a mixed environment over time as you do?
Sure. Sure. That's another good question. So I will repeat that. So the question was, in a mixed environment, obviously we're not the only one out there. In a mixed environment, it actually plays really well as well, because again, to some extent, there is a standards-based component to this. So if and there are, Huawei, 3Coms or HPs on that space, Alcatel-Lucent's on that space. There's a whole bunch of vendors that are already in that space. But even if you're an existing, say your existing network is Cisco or whatever, and they're not playing in this space, we could take their edge devices and bring them into a core, for example. So my other example I just mentioned with Peter, exactly the same. So you could convert your core to SPB, have an SPB core, and then you could have legacy edge devices that come out there. And so you've significantly saved your core. Or conversely, you could start to work on the edge side. So it really does depend. We do fully interoperate as well. If you think about from an MLT point of view, we interoperate with all of the other vendors, with Cisco from a VSS point of view, and so on. So you can get and paste together something. It's not 100%, like in terms of you're not going to get all of the network functionality, but you will get a lot of the advantages. And the further you put it out, SPB out, the more advantages you're going to get to the edge. Same sort of idea. Does that answer your question?
Yeah, just maybe to probe a little bit
Sure.
more. Have you gotten or done demonstration or working on SPB with other vendors?
Yes. So so the question was, have we done interworking with SPB? Absolutely. Like I said, I think there's about 8 or 9 vendors that are doing SPB interop today. That's a big piece of what interop is about. Yeah. So through interop, they've been doing a number of testings. We had all of those vendors participating. But remember, today, the standard is really for SPB at layer 2. It's a layer 2 service. It's predominantly viewed at for the data center play. And that's usually where the interop comes in. What we've proposed is that we think this could go beyond the data center into the entire network. There is a number of drafts that are out at the IETF now. There's one, it's called the Unbehagen draft, and that's one of our chief architects, Paul Unbehagen, and that's talking about the layer 3 VSN services, the IP shortcuts, and the multicast. So those are being put forth as draft extensions to the IEEE and the IETF drafts that are out there today. Okay, any other questions?
I'll belabor one more. So
One more.
I've got an edge switch today.
Yep.
It's connected through a split MLT
Yes.
to two different core switches.
Yes.
And it's a switch that obviously is not going to support
The edge switch.
The edge switch. It's an edge switch that's not supported.
Right.
So how does that play in a SPV?
Okay, so in a so the question was, how does a traditional edge switch, and this could be a competitor's edge switch, that has two links into your core. If your core is SPB, what that means is that you now no longer have to reprovision any of the core boxes when you want to deploy a service. So all I have to do is I would have my two edge devices. Let's say I want to deploy a VLAN at the edge. Okay, so I only would have to touch the two core boxes where those edge switches connect and say I want to provision VLAN 5 and VLAN 5. I wouldn't have to touch all the other devices in the core. That's the significant difference. And you can live in that environment. So you can have SPB in the core, and you can have MLT or VSS or any kind of other link aggregation technology going out to those legacy devices, and they would fully be supported. The advantage of having SPB down at the edge device would be the fact that you now, if you wanted to make a change, you would only have to touch that edge device. You wouldn't have to touch the two core devices. You see what I'm saying? But if you had 20 boxes in the core, you still only have to touch two to add the service. So that's kind of where the advantage would be. Perfect. Okay, thank you very much for your time today. And I encourage you, if you get a chance to come and see the demo, it's quite enlightening, and it's kind of interesting to see how it actually works. Thank you.
You're like a metronome, John. Spot on time.
Yeah, I told you, I'm usually pretty good for time. Yeah.